So while you're finishing up those, I'm just going to remind you that tomorrow, remember, it's that groovy schedule in the morning because we got that speaker right away, and then we got Battle Royale. Okay, so remember your 3 homeworks are still due. You had the blue one from last week, you had the yellow one from Monday, and you had the green one. Yep, green one from yesterday. Okay, so those 3 are due tomorrow, even if you have class or if you don't. Okay, you can drop them off in the resource center, you can drop them off in my office, bring them to Kruger's classes or my class, my 11 o'clock class, whatever. Okay, and then we're taking a formative assessment tomorrow, so get that done. If you don't have off time tomorrow, Kruger and I will both be here at 7 in the morning to help you out so that you can get it done tomorrow. Or we'll stay after school tomorrow too.
So we should be back by 10, right?
They say mod 9,
I heard of
but yeah, you don't. It's one of those things where if somebody's jamming up on stage, they're jamming, and you're not gonna stop their jam.
Sure.
So yeah. So it really only affects my 9 o'clock class and Kruger's 10 o'clock class. Because the 11 o'clock class should have enough time no matter when we come back.
Yeah,
So.
and that 10 o'clock class.
So then you just take the wrong day in the MRC.
Sure, or come find us again too. Yeah, I'll put a stack of them in the MRC for people to. They'll probably be sitting on the back table, so you don't have to go digging through them all. Okay. All right. So here we go. I should have tested this before we. Okay, good. Yay. All right. So first one, got a factor. X, I want to say -3 and x minus 1 there, and 2 times x minus 1 there. Okay? So my common denominator here is 2. I need an x minus 1, and I need an x minus 3. 2x minus 1. And an x minus 3. Okay, so what's missing in the first one? The x minus 3. Oops, let's go. What's missing in the second one? Just the 2? Okay. So, multiplying these 2 out, okay, you've got everything from yesterday, so you're good there, okay? What's up?
Does the 2 have to be right by the x minus 1, or could it be by the x minus 3?
That's it, as long as it's on the bottom somewhere,
Okay.
I'm fine. Yep.
Okay, cool.
Yep. Okay. So x squared minus 3x plus 2x is minus x minus 6. Now here's the kicker, because this one was a subtraction sign in between, so this really is negative 4x, right? But minus negative 4x is plus 4x. This one is really minus 2, but minus negative 2 is plus 2. And then all over 2x minus 1, x minus 3. Okay? So then that becomes x squared plus 3x minus 4 all over 2x minus 1 and x minus 3. Uh-oh, guess what? This top factors, doesn't it? Into x plus 4 and x minus 1. And why is that important? The x minus 1 cancel each other out. Yep. So then that leaves me with, way down here, oops, I'm going to have to extend the page. That leaves me with x plus 4 over 2 times the quantity x minus 3. Right? Restrictions? X x can't equal, no, positive 3 and 1. Yep. If I look here, x can't equal 1 from that one, x can't equal 3 from that one. Fantastic.
You take the restrictions out of your answer or out of the
Both.
initial?
Both. Mm-hmm. Okay. Factor all your parts, right? In number 4. Okay, so then this one would factor out a 3x. That leaves me with x plus 4. This one, x minus 1, x minus 1. This one, 7, and x minus 1. Right? Then what crosses out? X minus 1, x plus 4. The 3. Anything else? I don't see anything else. What's left on top? 5 x cubed, because there's 2 of them here, and there's 1 tucked in there yet. So 5x cubed, and an x minus 1. What's left on the bottom? 7. Do I have any restrictions? What are they? X can't equal negative 4 from this original one right here. And x can't equal 1, you said, Kevin? From this one right here. The 7's okay and the 3's okay. Yep. Questions on either one of those two? Okay. There will be problems like that on your formative tomorrow. Okay. And then there will be problems like this one on your formative tomorrow. Okay. How can I solve the first one?
Cross multiply.
I can cross multiply that one because it's fraction equals fraction. So here I get 3x, and here I get 60. Divide, correct? Giving me x equals 20. Okay, are there any restrictions in the original problem? Nope, so x equals 20 is my answer. Okay, checking it, quick check, 20 over 12. Both can be divided by 4. That reduces to 5/3, and 5/3 is equal to 5/3. Bada bing, bada boom. Checked out. Yep. Questions on that one? Okay. Other one. How can I solve it?
Also cross.
I can. Yep. Okay. Cross multiply, right? Okay. Right? So then that's going to be x plus 3 times x plus 5. And then the other one's going to be, whoa, we jumped. We're just erasing. That one's going to be 0 then, and then that's going to equal my other one. Was this? Okay. Do I need to multiply it out? No, because when I do multiply it out, then I'm just going to factor it back to what that is, right? Okay. So this tells me then that x plus 3 equals 0. So x equals negative 3. This one over here tells me that x plus 5 equals 0. So x equals negative 5. Do I have any restrictions in this problem? x can't equal negative 5, right? So what happens with this one? This one goes away, so that leaves me with just x equals negative 3. Okay? Questions on those two? In your book, I don't know how much space there is on page 629 to do that problem, but I think there's enough space to do that problem. Because it says solve it, so I'm guessing that they gave you some space. If not, if you wanted to do it on a separate sheet of paper, that's fine too.
Yeah, there's some good space.
There's some good space there? Oh yeah, plenty of space there on that one. Alright, so let's solve this equation. Okay? What's the first thing that we should do? Factor all the denominators, right? Okay? First denominator, does it factor?
Yep.
Yes. Okay, so that gives me x and x minus 2. And the other denominators that factor?
No.
No? Okay, now I'm going to show you kind of a cross today between the two methods that I should, well, first off I should ask, can we cross multiply this problem? Why not? KG? There's 3 fractions, and we can only cross multiply if there's 2 fractions, right? Okay, so we can't cross multiply, so that leaves methods 2 and 3 that we learned yesterday. Okay, now I'm going to show you an alternative, kind of the way that I do it. If you choose to do it that way, hey, more power to you. If you've got your own method of doing it, hey, more power to you. If you want to use the methods that we taught you yesterday, hey, that's great, whatever. Okay, giving you options here. Okay, so give me a second here to write this one down. 10 over x times x minus 2 minus 1 over x equals 3 over x minus 2. Okay? Now, method number 2, yes, what's up? It's addition. Oh, it is addition. From this angle right here, I can't see the plus because of that light right there. Okay? Alright, so addition. Alright, so now, yesterday, method number 2 told us to get rid of the fractions, right? Okay? And method number 3 told us find the common denominator and then forget about the denominators. Okay? Either way, you're finding that common denominator in it. Okay? So the way that I go about doing it is I'm going to multiply this term by x times x minus 2, even though that's a bad x minus 2. Okay, because that's my common denominator. And I'm going to multiply this term then by the same thing. And I'm going to multiply this term by the same thing. And I write it up there. Okay? Now here's why I do that. Again, this is me. This is how I roll. Okay? This x here is going to cancel out that x. This x minus 2 is going to cancel out that x minus 2 just on, I'm just looking at that first fraction. I'm simplifying that fraction. And so all that's left in there is 10. Okay? Now I'm going to go to the next fraction. And again, in green, this x is going to cancel out that x, and all that's left in that fraction is x minus 2. Then I'm going to go to this last fraction, and this x minus 2 is going to cancel out that x minus 2, and all that's left, bless you by the way, is 3x. Okay. Which is, if we would have done method 2, which is what we would have gotten in that next step. If we would have done method number 3, we would have gotten that had we forgotten about the denominators after we adjusted them all. Okay?
So again, giving you options here. So this becomes x minus 8 equals 3x. That becomes negative 8 equals 2x. And so I get negative 4 is equal to x. Right? Okay. Restrictions from way back up in the original problem.
Positive 2.
Positive 2 is weak, so x can't equal positive 2
And 0.
or 0, right? Did I get positive 2 or 0 for that one? Nope. So that's my answer. Yes, ma'am.
I guess I'm just like kind of confused. Like, how come we can just like multiply x times x minus 2 to all of them?
So times all of them.
Yeah.
Okay. So if do you remember back in Algebra 1 when they first taught you about equations and they used the scale? You know what I mean? Okay. So if you multiply one side by that, you got to multiply the other side by that to keep it in balance, right? Okay. So really what I did up here is I multiplied this right side by that, right? Well, that means I'm going to have to multiply this left side by that, which because there's two terms on it, I'm going to have to distribute that into both terms. So I'm going to have to multiply the first term by it and the second term by it. So you got to multiply the whole thing, every single term by it.
So like, could you do like multiply all of them by like x minus 2 then? Okay.
Also, it doesn't matter which one you multiply by.
What do you mean?
Like what she just said. So how do you find the red one?
So the red one that I multiplied by, so
Yeah.
that was my common denominator.
So you just find the common.
Yep. So because on method 2 and method 3, you're finding the common denominator. So you're doing it, and then it's kind of like it's like method 2.5.
Yeah. So you just leave the denominator.
Mhm. Okay. Does that clear that up for you? Okay. All right. So I want to say that if you turn the page, it's probably in there somewhere. It's F. It's letter F.
Yeah. It's on
So it might be 2 pages.
630.
Yeah.
Okay. Yep. So why don't you guys try that one, and then at the same time, we'll use these both kind of as your exit tickets today. E and F, because they're both on the same page. Yeah, let's do those two. Yeah. See, here we go again. That goes up there. Okay. All right. So can I cross multiply these two? Yep, because there's fraction equals fraction. So we get 9 times x minus 5, and that's going to equal these two. 8 times x minus 2, distributing 9x minus 45 equals 8x minus 16. Subtract 8x. At the same time, I can add 45. So I get x equals 29. Okay, and my only restriction here was x cannot equal 2. 2 is not 29. So 24 over 27. Yep, 24 over 27 reduces down to 8/9. Yep. Okay. All right. Give you a little more time. A little more time on F, or are you good with it?
I'm confused.
You're confused? Or are you just confused and need me to do it?
Can you just show us how to do the common denominator?
Okay. So first off, what do you got to do?
Factor the x.
Factor. Yep. Okay. So this one
Doesn't factor.
doesn't factor. This one,
Take
take
that out.
a 5 out. And this one,
Butt cheeks. X minus 1.
oop, that's a bad x minus 1. But yeah, do the butt cheeks, x minus 1, x plus 1. So my common denominator then is
5x plus 1.
5 and x plus 1 and x minus 1, right? So multiply that by every term, or adjust your fractions, or
I didn't see
write what's missing on top, or yeah, you know, there's.
I didn't see the factoring for the 5.
Oh, okay.
Yeah, that's fine.
Okay. Just keep going, Alexa. You make the call. You're probably too young to remember Hee-Haw. You know what Hee-Haw is? Hee-Haw was a great show back in the 70s. And they had this little segment where it was Buck Owens and Roy Olson, I want to say. Roy Clark, that's it, Clark. Okay? And they were picking and they grinning. So you pick and I'll grin. Okay. All right. So, got to multiply every term by that common denominator, right? So, I think I can write it up in here. 5x plus 1, x minus 1. 5x plus 1, x minus 1. 5x plus 1, x minus 1. Okay? So, this x minus 1 is going to cancel out that x minus 1. So that's going to leave me with 5 times x plus 1. This x plus 1 and that 5 is going to cancel out those two. That leaves me with plus 2 times x minus 1 equals, both of these are going to cancel out both of those, negative 3 times 5. Yes? Go.
What about the 3?
What about the 3?
Fraction.
Oh, did I miss the 3? I missed the 3. So let's put a little 3 right there. Was that your question too, Steph? Or Jackie, whichever one had your hand up? Yeah? Okay, yeah. Guy can't be perfect all the time. Okay? Okay. So then this becomes 15x plus 15 plus 2x minus 2 equals negative 15. Before I scroll down, what are my restrictions in this problem?
0.
Can x equal 0?
Because you have x.
X can equal 0.
Oh.
Plus or minus 1.
Plus or minus 1, right?
I thought it was always 0 if you had an x squared.
If it's just x squared term.
Oh.
But we don't have just an x or just an x squared term. Yep. Okay? So if we get one of those, we got to kick it out. Okay? So then this becomes, what's that? 17x plus 13 equals negative 15. Yeah? So 17x equals negative 28. So x here equals negative 28 over 17. Yes? Yeah? Okay. Not negative 1, not positive 1. So that's my answer. Yeah, but. Okay. So tonight I'm going to give you a purple homework. This purple homework will be due next week, Friday, which is also the day that we're going to take the Chapter 8 test. Okay? I would recommend, and this is just a wink, wink, nudge, nudge, hint type of thing, I would recommend that you do some of these purple problems tonight in preparation of your formative assessment tomorrow. Wink, wink, nudge, nudge. Okay? Have a great day. Remember, tomorrow you've got that goofy schedule in the morning, so if you don't have class, make sure that you get your stuff turned in and done.